Okay, so we're going to look at the second part of the discriminant today, and I'm just going to keep referring back to the three pieces of information which we've seen many times before. So if we've got two real roots, the b squared minus 4ac is bigger than 0. If we get one real root, b squared minus 4ac is equal to 0. And if we've got b squared minus 4ac is less than 0, then we have 0 real roots. Okay, so we're going to look at the first example, and the question asks us to find the value of k so that we have two real roots. So if we have two real roots, if we refer back to the top, that means that b squared minus 4ac is bigger than 0. So I need to set it up so that b squared minus 4ac is bigger than 0. Okay, so lifting the information down, b is 6, so I have 6 squared minus 4 times k for my a, times minus 2 for my c, and that must be bigger than 0. Tidying it all up, you get 36 minus 4 and minus 2 is plus 8 times the k is bigger than 0. Well, then you're just solving a normal inequality that we did last year. So take 36 to the other side to get minus 36, divide by 8, and then you must always simplify your fractions. So we're going to divide it by 4, and you get minus 9 over 2. Okay, so that's your first. Okay, we're going to look at example number 2, and we've got to find k given that x squared plus k minus 3x plus k equals 0 has non-real roots. So your roots are either real or they're not real, which we don't really need to go into non-real roots, but if the roots are non-real, that means there are 0 real roots. Okay, so if we have non-real roots, we're looking for b squared minus 4ac to be less than 0. Okay, filling this in from the information above, my b is k minus 3 minus 4 times 1 times k, and that must be less than 0. Put the square in. Multiplying out the brackets, right, so that would be k minus 3 squared, which is k minus 3, k minus 3. So you got minus 4 times k, it's minus 4k, less than 0. Multiplying out the bracket, doing it quickly, I get k squared minus 3k is minus 6k, minus 3 and minus 3 is plus 9, minus my 4k from the end, gets you that, tidy it up again, gets you k squared minus 10k plus 9 is less than 0. Now, this is where we use our experience from previous lessons. This is now a quadratic inequality, and the method that we used to solve quadratic inequalities is finding the roots and doing a sketch. So do the roots first. So you do k squared minus 10k plus 9 equals 0. Factorise it, gets you k minus 9, k minus 1. So therefore my roots are k equals 9 and k equals 1. Okay, now to solve that, I need to then do a sketch. Very quick sketch. I'm not looking for a great deal of detail. 1, 9. For my roots, check the quadratic inequality. It's a happy one. So therefore, it's coming down and it's looking like a U. And we're going up like that. So I've got my curve drawn now. Check the inequality now. Now the inequality it wants to know is, when is this curve less than 0? This curve is less than 0 between 1 and 9. So I'm looking for the solutions between 1 and 9. So I put 1 and 9 down, and I know I want all the values for k between 1 and 9. So k must be bigger than 1, but less than 9. And when you do these ones, make sure the inequality signs go in the same direction. And that is your final answer. Okay? Example number 3. So this time we're going to find the range of values for m so that mx squared minus 4x plus m has real roots. Now, that means that your b squared minus 4ac, now because we've got real roots, your b squared minus 4ac, when it's bigger than 0, gives you 2 real roots. So I know it must be bigger than 0. However, if I have 1 real root, b squared minus 4 equals 0. So rather than doing it twice, I can change the inequality so that it's bigger than or equal to 0. And then you're going to solve it as you have done. So put your b in. So my b here is minus 4. So I've got minus 4 squared minus 4 times your m for your a times your m for your c. Okay, so multiplying this up and tidying it all up gives you 16 minus 4m squared is bigger than or equal to 0. Again, it's a quadratic inequality. So I'm going to find my roots, and I'm going to do 16 minus 4m squared equals 0. Factorise it by common factor first of all. I know you could do difference of squares straight away, but we're going to go common factor first of all. Common factor of 4 gives me 4 minus m squared equals 0. And then I'm going to go 4, and it's 2 plus m, 2 minus m. And therefore my roots are m equals minus 2 and m equals 2. Okay, and then we're going to do it with a sketch. So I've got minus 2 and 2. The x squared, or in this case the m squared, is negative. So therefore, it's upside down. Okay, so just bear that in mind. If your m squared or your x squared, whatever yours you're sketching, is negative, your curve is upside down. And then I'm looking for when is this bigger than or equal to 0. So it's bigger than 0 between minus 2 and 2. So just like before, it's between minus 2 and 2, and m is bigger than or equal to minus 2 and bigger than or equal to 2. All right, so just make sure this matches up. Okay, and that's you. Okay, so we're going to look at example number 4. This time we've got to find the range of the values of k so that k bracket x squared minus x plus 1 bracket equals 1 has 0 real roots. Right, the first thing to say about this example is you're only able to do your b squared minus 4ac because we're talking about the roots. This expression must equal 0, so therefore I need to make it equal 0. So what I'm going to do first of all is I'm going to multiply the bracket by k to get kx squared minus kx plus k. And then to make this equal 0, I'm going to bring the 1 over to join it. So it becomes minus 1 equals 0. Okay, now if we're talking about 0 real roots this time, then your b squared minus 4ac must be less than 0. Sub it in our solutions, our values, so that your k is, your minus k is your b. So you get minus k squared minus 4 times k for your a, times k minus 1 for your b, your c, sorry, is less than 0. Multiplying this all out, tidying it all up, minus k squared is just k squared. Minus 4 times k is minus 4k for the first two, times minus 4k through the bracket leads to minus 4k, and then minus 4k times minus 1 is plus 4k. Okay? So less than 0. Right, tidying this up, so you got your k squared minus 4k squared is minus 3k squared plus your 4k at the end is less than or equal to 0. Right, we've got another quadratic, we've got a k squared and a k. So to solve the quadratic inequality, you do your roots and you do a sketch. So I've got my minus 3k squared plus 4k equals 0 for the roots. Now this is just a common factor factorising, and that's a common factor of k. So I get minus 3k plus 4 equals 0, and then each expression with a k is made to equal 0. So k equals 0, minus 3k plus 4 equals 0. So I would take the 3k to the other side to make it positive, and then divide by 3, so you get 4 over 3. Alright, do a little sketch. And you are looking at 0, 4 over 3. That's your 2 roots. Right, before you do your sketch, you need to check, is the k squared positive or negative? It's negative. So therefore, the quadratic is upside down. Alright, and then you need to check the inequality to see which parts of the sketch you're interested in. And I want to know, when is this expression less than 0? So it's less than 0 here and here. So for this little section, it's all the values before we get to 0. So k must be smaller than 0. And for this expression here, we write that in, it's for every value of k which is bigger than 4 over 3. So therefore k is bigger than 4 over